All right, so we're talking about the remainder theorem today, and so by the end of the lesson, you'll be able to divide polynomials and use the remainder theorem. Now realize that dividing polynomials should be reviewed from Algebra 2. We did that there. However, the remainder theorem we did not mention or talk about last year, and so here this year. So, what is the remainder theorem? Okay, well the remainder theorem basically says that if a polynomial f of x is divided by x minus c, okay, that's a linear factor, then the remainder is r, which equals f of c. Okay? So basically you have a polynomial function, some long thing, x to the third plus 2x squared, whatever. It's being divided by a linear factor, x minus 3 or x plus 2. Well, the remainder is what you get if you were to do long division, is whatever you would get at the end, whatever was left over, right? That can also be found by basically taking whatever c is, and then, what does that mean? Plugging it into f. So you can find your remainder either by doing long division or
By plugging it into F.
synthetic division, or also by plugging it into f. Okay? Now, this indicates that to evaluate polynomial functions, you can divide using division. So there's two different types, there's long and synthetic. Now realize that, long division is kind of like that surefire go-to, okay? No matter what, if you divide using long division, you will always get an answer. Synthetic only works when it is a linear factor, okay? So that's x plus 2, x minus 1, x plus something, or x minus something, okay? You cannot use synthetic division for an x squared plus 2, okay?
Yes.
So long division would have to be used there. So I'm not going to take the time to go over long division because what we're basically getting into deals with linear factors, and so I'm just going to go over synthetic with you guys. However, if you want to refresh your memory, stay on top of things, I will put a video up onto Google Classroom so that you can watch and refresh your memory on long division. But synthetic, let's take a look. We're going to find the remainder, and we're going to do it both ways. We're going to do it using synthetic division and also using the remainder theorem. So, here's our polynomial. We're going to divide it by x minus 1. What features do you guys remember about synthetic division?
Box.
I need a box, or I got half L.
Oh, then you're going to put one x minus 1 in there.
No, you're going to put one. Just one. It's always the opposite here. It's always the opposite of that.
And then you're going to put 4, 21, 25, negative 5, and
And then you put your coefficients. If I'm ever missing a term,
put a 0.
you gotta put a 0 in. So say that that 25x squared wasn't there, then you would have to put a 0 as a placeholder. Now I'm looking for the remainder. The remainder always is found
At the end.
at the very end. So I like to put another backwards L type thing, upside down L, at the end, so that way I know whatever's in that spot, that's my remainder. First step,
Bring down.
bring down the 4.
And then you multiply.
And then you multiply 4 to whatever's in the backwards L. So what's 4 times 1?
4.
And then you
Add
add 21 plus 4 is,
25.
and then you repeat the process. 25 times 1
25.
goes right here. Then you,
Add.
and that is 50. Repeat the process. 50 times 1,
50.
then you
Add.
add. So negative 5 plus 50 is,
45.
multiply again to give 45. And then it tells me my remainder is
48.
48. Now realize it just asked me for what my remainder was. It didn't ask me, to just divide the function by x minus 1. If it did that, then we know that whatever is here to the left of the remainder is my quotient, which would be 4 cubed, because you always lose a degree when you're dividing. And then your remainder would be written as
over x plus 1, right?
a fraction. That's how you write it. It just asked you to divide. Okay, so do not forget that back from Algebra 2. However, it was just asking us for our remainder, which is 48. Now I could have found that very same answer by doing the remainder theorem, which says to basically take C, which in this case is 1, it's the opposite, and plug it into the function. 1 to the 4th power is, so that's just 4. 1 to the 3rd power, so that's just 21. 1 to the 2nd power, so that's just 25. That's a negative 5, and that's a positive 3. Then all I need to do is add those numbers up. 4 and 21 is 25. 25 plus 25 is 50. 50 minus 5 is 45. Plus 3 is 48. So no matter which way you do it, synthetic division or the remainder theorem, you'll get the same remainder.
But what did you, oh wait, no.
So you're doing the next problem on you. So on this one, to find the remainder, if I use the remainder theorem, I'm plugging in a negative 3 here into this formula. So it's going to be 4 times negative 3 to the 4th power. Negative 3 to the 4th power is, I don't hear no one who used their calculator. That. It is 81. Because negative 3 to the 4th power, that's just negative 3 times negative 3, which is, and then it's another negative 3 times negative 3, which is, 9 times 9 is 81. You didn't need your calculator to do that. Plus 21, and then negative 3 to the 3rd power is negative 27. Plus 25 times negative 3 to the 2nd. You definitely didn't need a calculator for that. What is that? 9 minus 5 times negative 3 plus 3. Okay? 4 times 81 is a simple multiplication. What's 4 times 8?
32.
And what's 4 times 1?
4.
There you go. Okay? This one's probably one that you might have had to do the long way. You know, bust it out old school. 21 times 27, 7, 4, 1, 2, and 4, 5, 6, 7. 25 times 9. Think of it like money. You have 9 quarters. How much money do you have? $2.25. So this is 225. Negative 5 times negative 3 is a positive 15. And then you have a plus 3 at the end. And then after that, it's just some adding and subtracting of numbers. Me personally, I probably would have added these two together to give 549. So then you can almost have basically, you know, these numbers are close to each other. 15 and 3, when you add them together, make what? 18. When you subtract these two big numbers from each other, they get a negative 18, which is 0. Exercise your brain, you can do it. You would also get the same number if you did negative 3 using synthetic division. Okay? Now, if you get a 0 as your remainder, okay, then that means that that negative 3 is something special. That means that x plus 3 is something special, okay? If you get f of c to equal 0, if you do synthetic division and you end up getting 0 as your remainder, that means that that x minus c is a factor of the polynomial. So when a polynomial f of x has a factor x minus c, if and only if f of c equals 0. So again, I'll say, if you end up with a remainder of a 0, that means that x minus c, whatever that linear factor was, is indeed a factor for that problem. That is known as your factor theorem. Okay? And if it's a factor, that means for that last problem, that negative 3, there was something special about it. Negative 3 would be what? A 0. So if it's a factor, that means that that c is a 0 of the polynomial. Okay? So, working working our way, building in all these things, okay? We know how to find zeros using quadratic formula or a variation of it and doing it that way. If you're given a factor, you can test to see if it is a zero or not, and then continue to go from there. Tomorrow, you'll find another way to do it that doesn't really involve factors, okay? So, until then, we'll keep continuing. So determine if the binomials given are factors of f of x. Use the binomials that are factors to write the factor form of f of x. So we're going to factor this cubic. I can't do it by grouping. I need to test these factors that are given to me. So, in this particular case, yes, you are going to have to do synthetic division here, because I have multiple ones to test. And the thing is, I'm trying to get the most factor form, okay? And so I have to break down this polynomial. So we're going to test -4. What are my coefficients? And remember, you guys, you're always doing the opposite of the factor. So I start by bring it down to 2. Then I multiply to get -8. -8 and -1 make. Multiply again to get. I'll add to get. Multiply again to get. And then add to get. If I get a 0, what does that mean? -4 is a 0, which means that x plus 4 is a factor. That's good. Now I need to test the other factor that's given to me. Now, I can use this form right here to keep going to test 5. And the reason why I can do that is because I had a remainder of 0. If I didn't have a remainder of 0, I would have to go back to the original and test that one. Yep. So on the side, we can just put 5 and keep on going. This time, our remainder is going to come underneath that -5. So we do it again. Drop down to 2. Multiply to get. Add to get. Multiply to get. So that means they both are factors. Now this is a 3rd degree polynomial, which means I should have how many factors? 3. Your last one is sitting right there in your face. 2x plus 1. That's your last factor. And you know it's 2x because you started with the cubic. When you first did your synthetic division, this was a quadratic. And then when you divide it again, this turned into a linear. So here are your factors. Jamie and then Shaka. Yes. Exactly. Good. So, yes, to repeat what Jamie said, she said if one of them worked and the other one didn't, then from the quadratic that you would have left over, you would factor it normally. Okay? California method or whichever other way you prefer to factor. Okay? Let's look at the next one. There is a change that needs to be made. I did a mistype. This should be a 3x to the 3rd, not a 4x to the 3rd. Okay, so change that to a 3. And now I want you guys to try to figure out which one of these works. If they both work, one of them clearly should work, so we haven't gotten to that point when none of them work. And then I want you to find the other 2. So you test them. To test, I'm gonna plug in I wanna use which one? 2. And it's a positive 2 because remember it's always the opposite of this. So I have 3, -1, -22, and 24. Don't forget, whenever you're missing a term, what do you need? That placeholder. Bring down to 3. Multiply. Add. Multiply again. Add. Multiply again. And add. What does that mean? That's a factor. Because it's a factor, I can check -5 with that. Repeat. Bring down the first term. Multiply. Add. Multiply. Is that 0?
No.
So that tells me that 5 or -5, x plus 5 is not a factor. So that one doesn't work. So now I take this and factor this. So California method, -36. 9 and -4, what goes on top? And when I simplify, I get
X plus 3.
and there's your factor form of this binomial. Questions? So, summary of today. If R is the remainder obtained after a division of f of x by x minus c, then the following statements are true. What are some of the things that we talked about? That when you divide and you end up with the remainder. What special things we talk about with that remainder?
If your remainder is 0.
If your remainder is 0, so if R equals 0, what's going to be a factor? Is R going to be a factor?
No,
X minus
the X minus C.
The x minus c is going to be a factor. What else do we discover or that we realize? If our remainder is 0, then not x minus c, but then the c is a 0. So remember, if we had a remainder of 0, then that meant that the 2 in this particular example was indeed a 0 of the function, because technically we set this factor equal to 0 and solve, right? So that means that 2 would be a 0. Just like x minus 2 would be a factor. The other two key pieces of information is that if your remainder is 0, then we know that it is a solution for our function. And then, of course, the remainder is what you get when you plug in the value of c into your function. And that is our summary for today.